Hi, good day everyone. So today we'll be doing May-June 2024, number 8. So the first question says the function f and g is defined as followed. F of x is 2x minus 1 over 3. G of x is 5 minus x squared. They want to know what is g of 2, meaning x is equals to 2. Let's zoom in. No. Ooh, that is too much. Right. So this would be 5 minus 2 squared. So 5 minus 2 squared is 5 minus 4, which is equals to 1. So g of 2 is equals to 1. This question here says g inverse of 3. Right, so we need to find the inverse. So we know that f of x is equals to 2x minus 1 over 3. Let y be equals to f of x. So y is equals to 3x plus 1. Am I saying 3x? It's 2x. 2x minus 1. Hold on. Let's write that properly. 2x minus 1 all over 3. Right, so we can go down so we could see. Then you interchange x and y, meaning wherever you see x equal y, wherever you see y equal x. So as x is equals to 2y minus 3 all of minus 1 all over 3. Excuse me. Then make y a subject. So that would be carry across 3. That is 3x is equal to 2y minus 1. You want to make y the subject, so you carry across 1. So that would be 3x plus 1 is equals to 2y. So y would be equals to 3x plus 1 all over 2. So f inverse of x is equals to 3x plus 1 all over 2. So f inverse of 3 is equals to 3 by 3 plus 1 all over 2. 3 3s are 9, 9 plus 1 is 10 over 2. So f inverse of 3 is equals to 5. And that would be the answer for this question here. Derive an expression in its simplest form for gf of g of x. So let's put f of x is equal to 2x minus 1 over 3, and g of x, what is g of x? 5 minus x squared. Right, 5 minus x squared. So this is what we call a composite function. When we have g f of x, the first thing that you do is put a bracket between the two functions. So that is between f and g. So what is g of x? It will be f of 5 minus x squared. Alright? So wherever we see x in f of x, you're going to put 5 minus x squared. So f of 5 minus x squared is going to be 2 by 5 minus x squared minus 1 all over 3, which is 5 2s are 10. That's 10 minus 2x squared minus 1 all over 3. You multiply this entire thing by 3 to get rid of 3. So you'll get sorry, no. Leave the divide by 3. 10 minus 1 is 9. So 9 minus 2x squared all over 3. So f g of x is equals to 9 minus 2x squared all over 3. And that would be the answer. Let's read this question here. Sketch the graph of the function g of x in the space below. on your sketch indicate the maximum / minimum point and the root of the function. First off, let's write what g of x is equal to. So g of x is equal to 5 minus x squared. Alright, let's put the squared first. So g of x is equal to minus x squared plus 5. The coefficient of x squared is negative, hence we have a max point. Right? Okay. So to get your maximum point, you have to get your axis of symmetry. Your axis of symmetry is minus b over 2a. Minus b, there's no b, so it's 0 over 2 by minus 1. Axis of symmetry is 0. Alright? So because your axis of symmetry is 0, you're going to substitute x is equals to 0 into the equation to get your maximum point. Right, into the equation at minus x squared. So it is going to be g of 0 is going to be minus 0 squared plus 5, which is equals to 5. So your maximum coordinate is 0, 5. So let's plot that point. Well, there's no numbers here. So 1, 2, 3, 4, 5. So let's go 1, 2, 3, 4, 5. Right, then we want the roots of the function. Roots of your function is when x is equals to 0. So when y is equal to 0. So when y is 0, right, that is 5 minus x squared is equals to 0. So we have positive x squared is equals to 5, so x is equals to plus or minus root 5. So x is equals to, what is the square root of 5? The square root of 5 is equals to 2.23 or negative 2.23. Now if we count how many spaces we have here, we have 1, 2, 3, 4, 5, 6 spaces. I would suggest put 1 centimeter as 1 unit. The 2 would be here and you'll get a kind of a very small graph. We wanted to, anytime you draw a graph, it has to take almost three quarters of your graph base. So I'm going to say this is 1, this is 2, and this is 3. This is negative 1, this is negative 2, this is negative 3, this is 0 here, this is minus 1, minus 2, minus 3, minus 4, minus 5, right? So let's just find some values. So first off, the axis of symmetry, where maximum coordinate is this, which is 0, 5. Alright, let's say when x is equals to negative 1, that's 5 minus 1 squared, which is 4. So that would be this coordinate right here. Alright, when it's positive 1, it's also this coordinate right here. When when it is negative 2, it's 1, so that's this coordinate right here. And that's this coordinate. It will be positive 2. When it's 2, it'll be also be 1. Right? Do I have space for 3? When it is negative 3, negative 3, it's negative 4. So it would be here. Right? Alright, so then you connect these points and make the line as smooth as possible. Your 2.23, so it is about here. Right, this here and this here, right, is known as your roots. So let us just see if I can make this as smooth as possible. Alright, so something that looks like this. Please note that always write your scale. On your y-axis, 1 centimeter is equals to 1 unit. And on your x-axis, 2 centimeters is equals to 1 unit. Right, this coordinate here is 0, 5. This is your maximum value. And this right here and this right here is known as your roots. Right? The roots of the function. That is when x is when the function is equal to 0. Or y is equals to 0. Alright, let's look at this part B. The graph below shows a quadratic function. On the grid above, draw a tangent to the curve where x is equals to 1. X is equals to 1 would be a line that looks, I will fix this. X is equals to 1 is this line right here. Sorry, I didn't read the question properly. They said on the grid above, draw a tangent to the curve. Tangent means it's just touching the curve at where x is equals to 1. X is equals to 1 right here. So you are going to take your ruler, right, and make sure it's simply just touching. Hold on, let's fix this a little bit better. So it's about here. Alright, so you want to just touch the curve at where x is equals to 1. So they said use the tangent drawn to estimate the gradient of the curve at where x is equals to 1. So I would use this point right here, and I would use where x is 1, y is 3, about that. Right, so this would be, let's see, how much is this? This is y is negative 1. This is 5, 10, 15, 20. So 20 spaces is equals to 1. 1 space would be 1 over 20, and therefore 5 spaces, sorry, would be 1 over 20 multiplied by 5, which is 0.25. So the coordinates here would be 0.25 and negative 1, and here x is equals to 1 and y is equals to 3. Right, so to get my gradient, we know gradient is equals to y2 minus y1 all over x2 minus x1. Right, we have 0.25 and negative 1. And the next one is x is 1 and y is 3. You can choose whichever one you want to be as group 1 or group 2. This is x1, y1, x2, y2. We have 3 minus 1 over x2, 1 minus 0.25, which is 4 over 0.75. Right, so 4 divided by 0.75 is 3.25. 3.25 or 3.25, and that would be the gradient of your cube. Okay, I didn't like that answer, so I moved to the next app. So let's see, on the grid below, draw a tangent line. So we want, let's bring up my ruler here. Alright, let's say right here. X is equal to 0 is right here. We'll draw that line with the green. Right, so if you move that, this coordinate right here, oh my god, yeah, that coordinate right there is x is equals to 1, y is equals to 3. Alright, the next coordinate is this one here, that is on your y-axis. X is equals to 0, y is equals to 2. Right, now if they ask for the gradient, let me just remove this ruler, right, which was the next question. I got a kind of weird answer, so that's why I chose to do it over. Right, we are going to use those two coordinates to get your gradient. So my gradient is equals to y2 minus y1 over x2 minus x1. Right, the coordinates is 1, 3, 0, 2. Yeah. x1, y1, x2, y2. Sorry, this is negative 2. Right? So it is going to be 3 minus 2 over 1 minus 0, which is equals to 5 over 1, where the gradient is equals to 5. That is a better answer than what we had here, and the line was not exactly touching, so I had to do it over. Yeah, alright, let's go to the next question. Alright, next question now is write the equation of the tangent y is equal to mx plus c, y minus y1 is equals to m by x minus x1. Right, you could use a graph to find out what is the y-intercept on all those, but let's just do that. We're going to use the coordinates 1, when x was 1, y was 3, 1, 3. We got a gradient of 5. Right, so that is y minus 3 is equals to 5 by x minus 1. So y minus 3 is equals to 5x minus 5. So y is equals to 5x minus 5 plus 3. So y is equals to 5x minus 2. Right, or if you don't know, we already found the gradient to be 5. Your y-intercept is where the line intersects your y-axis. It intersects my y-axis at negative 2. So you could have done that. And that would be the end of number 8.